Today we are going to learn how to graph polynomial functions of a higher degree. We've already learned how to graph linear functions. We've also learned how to graph quadratics. Now the strategies for graphing, or first we're going to talk about end behavior. And this is a new term. So what we're going to look at is the exponents and the sign on the leading coefficient. So again, we need to make sure it's in order from least to greatest of greatest to least of exponents. So an odd degree is going to have opposite behavior at each end. And what I mean by an odd degree, I'm talking about an odd number. So I'm talking about, for example, an x cubed, an x to the fifth, an x to the seventh. It's going to take on the shape of the x cubed graph, and it's going to go in opposite directions. So it's going to fall to the left, but rise to the right. Understand this terminology, because again, you're going to be looking for multiple choice answers. So again, if A is positive, so it's a positive 1 here, then the graph will fall left and rise right. If it's a negative number in front of your variable, so like a negative x cubed or a negative x to the fifth, then this one's going to rise to the left but fall to the right. And that's what it states here. So when the power is an odd number, the direction of your graph is going to be opposite. However, when it's an even degree polynomial, meaning it's like a quadratic, so like an x squared or an x to the fourth, x to the sixth, then if it's a positive number in front of the variable, it's going to both go up. It's like the quadratic, so it almost looks like a U. When this is negative, then both ends are going to point down. So on this one, it's going to rise to the left and rise to the right when it's positive, when A is positive. When A is negative, it's going to both point down, so they're going to fall left and fall right. So understand the end behavior, because once we find the zeros, we're going to add this end behavior into the leftmost zero and to the rightmost zero. Next, we're going to talk about zeros and multiplicity. So for the zeros and the multiplicity, we're going to find the zeros like we've been doing. We're going to use synthetic division. We're going to break it down to quadratic, and then we're either going to factor it or use quadratic formula to find the other zeros. Now, another name for zeros are also known as roots or solutions. When they're asking us to list all zeros, we will also list the imaginaries. So, however, when we want to find x-intercepts, we're only going to list the real zeros or the real roots. So the zeros are also x-intercepts, but the x-intercepts are only the real zeros. Next thing we're going to talk about is multiplicity. Now, back to finding the zeros. If you're given the opportunity to use your graphing calculator, you can key the function into your graphing calculator. You can use that calculate feature I showed you on the Friday before the break. You mark the left bound and the right bound, and then it zeroes in and finds that zero for you. You can use that feature if you're using a graphing utility. However, if you're not using a graphing utility, then you have to make your list of possible zeros and then start guessing and testing and doing synthetic division until you find the one that works. Now, for multiplicity, this is where we're going to count how many times a root or a zero or a solution occurs. So when it occurs an even number of times, then that zero is just going to, when we go to graph it, the graph is just going to come in, it's going to hit the x-axis, and then it's going to turn away. It's like a bounce. So it's a touch and turn. However, if your 0 occurs an odd number of times, then your graph will cross the x-axis. So for example, what I mean by this, let's say we found 4 zeros. Let's say we got x equals 1, x equals 1, x equals 2, and x equals 3. Notice the 2 zeros here, x equals 1. This happens or occurs 2 times. I have 2x equals 1. So because 2 is an even number, then this has an even multiplicity. And when I go to graph this, it's going to come in and it's going to touch the x-axis and it's going to turn away. Another way to describe it, it's like a bounce. So for example, let's say this was my graph, and at +1 here, let's say my graph was coming in here. Instead of crossing it, it's going to touch at +1, and then it's going to bounce back down. This is an even multiplicity. Now, notice x equals 2 and x equals 3. Each of these occur 1 time. 1 is an odd number. When you have an odd multiplicity, this is going to cross the x-axis. So for example, if my graph was here, 1, 2, 3. So when I were to, let's say I put my points on my 3 zeros. So what would happen here probably, it would come in here, maybe it would come in, and then it would cross through, and then it would cross through. Notice at the 1, it was the bounce, it didn't cross, but at the 2 and the 3, it crossed. So when it only occurs an odd number of times, it's going to actually cross the x-axis. Now we're still doing all the work that you did in 3-4. However, now we're going to take that polynomial, we're going to graph the zeros, the y-intercept. We also have to find additional points. And we're going to use the remainder theorem, or we could plug in numbers into the original equation to get our additional points. So let's go ahead and try our first example. So my first example is going to be x cubed plus 2x squared minus 4x minus 8. Now, I actually put in a screenshot of Desmos just so we can see what it looks like. Now, when I zoom in here, notice it's got only 2 order pairs that are my x-intercepts. But notice at the -2, you see how it didn't cross? So this is a clue that tells me once I do the synthetic and factor it, -2 is going to occur 2 times. It's an even multiplicity. Now, notice also my biggest exponent is an x cubed. Remember, the end behavior for an x cubed is going to fall to the left and rise to the right. And that's what's happening here in my Desmos graph. It's falling to the left and rising to the right. Now, I need to find the zeros. Now, this is a reasonable question that you might get on a test where you're not using your graphing calculator. I would do my list of possible zeros. And what I would do here is factors of the last are 8, so plus and minus 1, 2, 4, and 8, all over plus and minus 1. So my possible zeros that you would have keyed into WebAssign on Friday or whenever you did the homework would have been -1, +1, -2, +2, -4, +4, -8, +8. Now, if you weren't using a graphing utility, now we have to start doing synthetic division until we find the one that gives us a remainder of 0. So this is my advice to you. When you're doing this, you're going to get a question like this on the test. It'll be multiple choice. You're not using your graphing utility, so you have to make this list. But I would look at my multiple choice answers to see the number that repeats in all the answers. That's the number you're going to do synthetic with. So I already graphed it on Desmos. I can see that -2 was one of the answers. So I'm going to go ahead and do synthetic with -2. I could have also done the +2. It doesn't matter. So now I'm going to take all of my coefficients, put it in. So 1, 2, -4, -8. So now bring down, multiply, add the column, multiply, add the column, and I got a remainder of 0. Now, if you weren't using a graphing utility and you weren't sure if -2 was going to work, all is not lost. The remainder you would have gotten would have been an ordered pair that we can graph later on. However, I knew this was going to work because I graphed it on my Desmos. So now, to get the other two zeros, because remember, it's an x cubed, I'm going to go ahead and add back my variables. So I'm going to add in x squared. So this is x squared. This is just the x. This is the constant. This is the remainder. So now I have x squared minus 4 equals 0. I can either use the square root method or I can factor it. I'm just going to factor it. Factors into x minus 2, x plus 2. And now don't forget about this one. I still had that one. So if it asks you to list the factors, these are factors. However, the zeros, you take each one, set it equal to 0, solve each one, these are the zeros, or the solutions, or the roots. They all mean the same thing. They're all real, so they're also all my x-intercepts. However, notice that when x equals -2, there's 2 of them. This is an even multiplicity. This is an odd multiplicity because it occurs once. Remember, the even is the touch and turn. This one's going to cross the x-axis. So it's going to touch the x-axis and then it's going to turn away. So now, just to graph it by hand, what you would have done, come over here to the side. So you're going to graph this by hand in the homework. There's graphs provided. I'm going to go ahead and put my x-intercepts on here. So I have a point here at -2, +2. I also have to go back and get my y-intercept. And again, I can go right back to the beginning. My f of x equals x cubed plus 2x squared minus 4x minus 8. Remember, it's just the constant, but just remember, you're plugging in a 0 here. For those of you who want to see the process, all of this cancels and you're just left with y equals -8. And remember, you plugged in a 0. So my y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, is right here. Now, the next thing I can do is add in my end behavior. So again, remember end behavior for an x cubed graph falls left, rises to the right. Now I have to figure out how it wiggles in between. Now, in order to do that, I need to find additional points. And the way that I can do that is either I can pick x values and plug it back into the original, or I can do synthetic division and use my remainder theorem. So what I'm going to do is the additional points I'm looking for are points in between these two zeros. I need to figure out how high or low it goes. Now, for this 0, for the -2, I know it's going to come up here and it's going to turn away, and then it's going to go down here to the y. But I need to figure out, after it leaves this y-axis, does it go down further or does it go back up to that one? So this is where I need to find an additional order pair in this section. And the way that I'm going to do that is I'm going to either plug in +1 into the original equation, or I'm going to do synthetic with +1, because that's the x value. So I'm going to do +1 synthetic. I'm using my original coefficients. Bring down, multiply, add the column, multiply, add the column, and I get -9. So now the remainder is the y of my order pair. This is the x of the order pair. So the order pair I can graph now is the order pair 1, -9. So now it actually goes a little bit lower, and we saw that in Desmos. So it's actually going to go down to here, and then it's going to go back up and go up to that 0. So you need to find additional points in between the zeros. Now, I could have also taken my original equation, the f of x, x cubed plus 2x squared minus 4x minus 8. I could have also plugged in 1 for each of these x's and gotten my y that way as well. So I could have done 1 cubed, 2 times 1 squared, and then get 1 plus 2 minus 4 minus 8, 3 minus 4 minus 8, -1 minus 8, and then f of x equals -9. Remember, f of x is just y equals. So again, you could have gotten the same order pair that I got when I did synthetic. Usually, using synthetic is a lot easier. Now, in your graphing calculator, let me just show you this one. I'll try to position my camera. If you are ever using a graphing utility, you can get that table of values and get your additional order pairs that way. Let me go ahead and get this keyed in here. Okay, let me position my camera here. To find additional points in between the two zeros. And this is basically all of the examples in the notes today. Some of them are already factored for you, so it's not so bad. But let's go ahead and try another one. So again, these are the strategies for graphing. You're going to first determine the end behavior by looking at that first term's exponent. Then you're going to find the zeros, find the multiplicity, find the y-intercept, and then also find additional points. So let's go ahead and try another example. So again, if it asks you to list the possible zeros, let's say we weren't using a graphing utility, we would end up putting plus and minus 1, 2, 3, and 6 all over the first, which is just a 1. So my possible zeros are -1, +1, -2, +2, -3, +3, -6, +6. So again, on a multiple choice test, look for the 0 that's the same in all the answers. That's the number you're going to do synthetic with to get the other two zeros. So next thing I'm going to do is look at my M behavior. Again, it's an x cubed. So again, it's going to fall to the left and rise to the right. So fall left, rise right. My y-intercept is just the constant. So it's 0, 6. And now what I'm going to also do is do the synthetic division. I'm going to choose 1. A lot of times 1 and -1 end up being a 0. So let me go ahead and do synthetic because that's one of the numbers in my possible list. So I'm going to put in all the coefficients. So 1, -2, -5, 6. Bring down, multiply, add the column, multiply. I messed up. Let me go back. That should be a -1. Multiply, add the column, multiply, add the column. Now, if you did not get a remainder of 0, then just hold on to that order pair because you can use that as an additional point. But this one gave me a remainder 0. So I did find one of my x-intercepts and one of my zeros. Now I'm going to add in the constant, remainder, constant x squared. So x squared minus x minus 6 equals 0. I now have to see if I can factor this. It's faster than doing quadratic. If it's not factorable, do quadratic to get the other zeros. This is factorable. It'll factor into x minus 3 and x plus 2. Don't forget about the 0 you already found. That was the x minus 1. So now, if it asks you to list factors, these are the factors. However, the zeros, you're setting them equal to 0. So this one gives me x equals 1, x equals 3, x equals -2. These are my zeros. They're also called roots. They're also called solutions. Next, I'm going to determine my multiplicity. Notice all of them. The reason why I chose 1 is I just picked a number out of this list and I did synthetic. If I would have not gotten a remainder of 0, then I would have had to do another synthetic. But I would have reserved that as an additional ordered point or order pair. Good? All right. All of the zeros occur one time. One's an odd number. So this has an odd multiplicity. This is going to tell me that all 3 of these zeros are going to cross the x-axis at each of these zeros. So let me go ahead and get all of these zeros graphed and my y-intercept. So I have one at +1, I have one at +3, and -2. I also have my y-intercept at +6. Now, I need to find additional points in between each of these zeros because I need to know how high or low to make my graph go. So if I'm not using a graphing utility, I am going to look for an additional point in between here, in between the y-axis, my y-intercept, and this 0. So I'm going to be doing synthetic division with -1 to get an additional point. Then I'm going to do another synthetic division because I need to get another 0 in between these two. So I'm going to plug in positive 2 to get an additional point. Now, if you're using a graphing utility, you would just open up that table to get additional points. Now, by choosing -1 and positive 2, this may not be the highest my graph goes or the lowest, but it's going to give me the direction to make the wiggle in between. So I'm going to take my coefficients from the beginning and put them into each of these synthetic boxes. And then 1, -2, -5, 6. So now to get my additional points, let me do this one first. Bring down, multiply, add the column. Multiply, add the column, I get 8. This remainder is the y of my order pair. So this is an additional point. Going to do the same thing with the positive 2. Bring down, add the column, multiply, add the column, multiply, add the column. So another additional point is 2, -4. So now I'm going to graph these additional order pairs. So -1, positive 8, it's going up above my y-axis or my y-intercept. So it's up here. So this is the order pair, -1, positive 8. And then I also have to put in positive 2, -4. So now, again, let me add in the end behavior. It's falling to the left, rising to the right, and now I can connect the points. It's going to come all the way up here to the -1, 8, and then it's going to come back down, hit that, and then back up to that 0. Now, one thing you can do to figure out how many turning points your graph has, you're going to take the exponent from the beginning, you're going to subtract 1 from it, and this tells me I will have 2 turning points in my graph where it changes from increasing to decreasing. So notice here, it was increasing, it hit this point and it turned. Now it's decreasing, and now it turns back again and it increases. So 2 turning points here. And then the next slide here is the Desmos graph. And notice, I ended up graphing the order pair -1, positive 8, but notice the highest it gets is actually 8.2. I'm not expecting you to do this by hand. I just need you to know that it's going to go way up above the y-intercept and then come back down. And notice here I plugged in 2 and I got -4. However, notice it went a little bit further. It went to 2.12. Again, you're just looking for another additional point in between the 2 zeros. So the next function that we're going to graph is this one, 2x cubed minus x squared minus 25x minus 12. That's going to be example 3. So I just wanted to show you what the graph is going to look like, and then we will graph it by hand. So what I'm going to get from here, I can show you the possible zeros. There's quite a few. However, we can see from here that the zeros are going to be -3, -0.5, and +4. That's why I'm going to go ahead and do synthetic division using the +4. Now, when I go to do this on the next slide, my additional point that I'm going to plug in, instead of -1.881, I'm actually going to plug in a -2, and what I end up getting is 18. Now, notice the highest point is this one, but I don't need to find the absolute highest point. I just want to see the direction it's going. And then over for this additional point, what I'm plugging in is I'm going to plug in +2 and I get -50. Notice the lowest it gets is the 2.215 and it goes as low as -50.547. So again, all I'm looking for is the general direction, how my graph is wiggling there in between those zeros. Now, if you were asked to list the possible zeros, remember what we would need to do is list the factors of the last term over the factors of the first term. So the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So my possible list would consist of making combinations of plus and minus 1 and plus and minus 2. So then I'd go through and list all the different combinations. So I would have positive and -1, 2, 3, 4, 6, and 12. That's with a 1 being in the denominator under each one. Now I'm going to do the same thing and put 2 underneath each one. So once I do that, positive and -1/2. 2 over 2 is 1. I've already listed it. Then 3 over 2, that would be 1.5. And then 4 over 2 is 2. I've already listed it. 6 over 2 is 3. I've already listed it. And then 12 over 2 is 6, and I've already listed it. So this is my list of possible zeros. And from there, if we weren't using a graphing utility, we would have to start guessing and testing until we find the one that works. However, we already graphed it, or I graphed it in Desmos, and I saw that my zeros, one of the zeros that does work is the +4. So that's what I'm going to do synthetic with to bring it down to quadratic, and then from there I can factor it. So if I do synthetic using +4, I need to fill in all my coefficients, 2, -1, -25, and then -12. I'll bring down, I'll multiply, add the column, multiply, add the column, multiply, and add the column. Now, I already knew I was going to get a remainder of 0 because I looked at the Desmos graph. However, if we had not used a graphing utility, I might have picked a wrong possible 0 from the list, and then I would have gotten a remainder here. Now, I could have used that ordered pair, though, as an additional point. But I do have the remainder of 0, so let me add back in the numbers. So remember, this is the remainder, the constant, the x squared. So 2x squared plus 7x plus 3 equals 0. Now that it's quadratic, you can either factor it or use the quadratic formula. This is actually factorable, so I'm going to factor it. It'll factor into 2x plus 1 and x plus 3. Now you can FOIL it to double check it. You should always do that. It does go back. It does FOIL. Now, also remember the 0 that we used, this we could also write as a factor. It's x minus 4. So if you're ever asked to list the factors, this would be the factors of that polynomial. However, it wants us to find the zeros so we can graph this. So I set each of my factors equal to 0. Solve each one. My first 0 is at +4, which I already knew. Subtract the 1. 2x equals -1. Divide by 2. X equals -1/2. Subtract 3. X equals -3. These are my 3 zeros. Remember, it's an x cubed graph. Also remember what we need to pay attention to is the leading term here is the 2x cubed. The a term here is positive. So this tells me it's going to follow this type of end behavior. My end behavior is going to fall to the left, but rise to the right. So I'm going to go ahead and also, from my original equation, I could also see my y-intercept. It's just this constant. So my y-intercept that I'm also going to graph is the order pair 0, negative 12. So let me go ahead and put these 3 zeros on my graph as well as my y-intercept. From there, I'm going to see where I need to look for additional points. So I'm going to graph positive 4, negative half, and negative 3. Now notice each one of these occurs only one time. So these all have an odd multiplicity. And remember, when it's odd, it's going to cross the x-axis at each one of these zeros. So I'm also going to add in my y-intercept. And again, my graph, let me make it go by 2 so it's not so bad. So this would be negative 2, negative 4, negative 6, negative 8, negative 10, and then negative 12 would be down here. So there's my y-intercept. Now, I need to find an additional 0. Okay, so now what we need to do is look for where we need to find additional points. So I definitely need to find additional points in between these 2 zeros here, between the negative 3 and the half. I also need to find an additional point in between this y-intercept or the y-axis and this 0 here. So I'm going to go ahead, instead of plugging in values for x, I'm going to do synthetic division. So for the order pair in between negative half and negative 3, I'm going to do synthetic division with negative 2. And for the other side, I can do synthetic division with positive 2. Again, any number in between would be fine. You could have plugged in 1, 3, any number in between 0 and 4 would be fine. So let me go ahead now and add in my coefficients here. 2, negative 1, negative 25, negative 12. I'm going to bring down, multiply, add the column, multiply, add the column, multiply, add the column. So the order pair I can graph is negative 2 and positive 18. I'm using my remainder theorem here. And then now I'm also going to do the same thing, synthetic division with positive 2 to get another additional point. Now again, if you'd rather plug it into the original equation, you could plug these x values in as well. So I'm going to bring down, I'm going to multiply, bring down 2, multiply, add the column, multiply, add the column, multiply, add the column. Wow, this one's going to go way off the graph. Positive 2 and negative 50. So let me go ahead and add in these additional points now. So this way I can tell where the direction my graph is going. So negative 2, positive 18. Again, I was going by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. It's still going way up here. So up here would be negative 2 and positive 18. So again, let me add in the last one, which will be way down here. So positive 2 and negative 50, I'll say, is way down here somewhere. So let me add in the end behavior. So again, remember over here, we said that it's an x cubed and it's positive. So the end behavior will be falling to the left, but rising to the right. So again, these are all crossing the x-axis. So I'm going to come up here to this point. Then it's going to turn around. It's going to come back down to this 0. It's going to hit the y-intercept. Then it's going to come down here to the 2, -50, and then back up. And that's your graph. And again, we saw it on the Desmos graph on the previous slide. So again, as we can see, if we go back to the Desmos graph, let's try another example. And again, we can see the M behavior here is a -x cubed. So this one's gonna rise left and fall to the right. And again, if I list my possible zeros, factors of 20 are plus and minus 1, 2, 4, 5, 10, and 20. All over plus and minus 1. So in this case, it's really just the numerator. So if you weren't using a graphing utility, what we would be doing here is guessing and testing using all of these possible zeros. Okay, so I made my list of possible zeros. I've already described what the end behavior is going to look like. So I went ahead again and keyed it into Desmos, just so I don't have to spend a whole bunch of time doing a bunch of synthetic division problems. So let's go ahead and take a peek at where my zeros are located. So if I zoom in here, you can see that I have a zero located at -5, -4, and +1. So I'm going to go ahead and do synthetic division with the +1 to break it down so it's quadratic. Then from there, I'm going to see if I can factor it. If not, I'll use quadratic formula. So let's go ahead and do the synthetic division. So again, set this up, put the 1 on the outside, which is a confirmed 0 from Desmos. Add in all my coefficients, -1, -8, -11, and +20. I'll bring down, I'll multiply, add the column, I'll multiply, I'll add the column, I'll multiply, and add the column. Again, I already knew that I should have gotten a remainder of 0 because Desmos told me it was a 0. So now let me add back in my variables. So a -x² minus 9x minus 20 equals 0. I'm going to factor out a -1 from each of these because I don't want to have to factor with a -x². So now what I can do is factor the trinomial. It is factorable. It'll factor into x plus 4 and x plus 5. Now again, if they ask you to list all of the factors, remember we have this original one that we did the synthetic with. So we have the -1 GCF we pulled out. Then we have the x minus 1, the x plus 4, the x plus 5, and it all equals 0. These are all the factors. However, the zeros are found by setting each of the factors equal to 0. I do not have to set a constant equal to 0 because that doesn't make sense. However, I will set the x minus 1 equal to 0, x plus 4, and x plus 5. I'll go ahead and add 1, x equals 1, subtract 4, x equals -4, subtract 5, x equals -5. And these were all the zeros that I saw in my Desmos graph. So now these are all the zeros. Notice they each occur only one time. So this has an odd multiplicity. So at each one of these zeros, my graph will cross the x-axis. I also need to find my y-intercept, and I can go back to the original. It's right here. It's the +20. So 0, 20 is my y-intercept. And now what I'm going to do is graph the 3 zeros and the y-intercept, and then I'm going to look to see where I need to find additional points. So let me go ahead and add in -5, 0, -4, and positive 1. Now my graph, I'm going to make it go by 2s just so it's not super high up into the words there. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'll say it's right about there. So now again, I can add in my end behavior. I'm going to add it to the far left 0, which is at the -5. And remember, it's rising left, but falling to the right. So now what I need to do is look for additional zeros. Now, I need to find an additional 0 over here in between the -4 and the -5. So I'm going to need to do synthetic division with -4.5 or plug it into the original. Either way. Now, I also need to find an additional 0 in this section. Let's see a color that'll show up. Let me try pink. I also have to find another point over here. And it could really actually go all the way from here. So I'm actually going to plug in -1. So for my additional points, I'm going to do synthetic division with x equals -4.5 and x equals +1. Now, I think what'll be easier to work with, instead of, you could work with it as a decimal. I'm actually going to turn -4.5 into -9/2. I think that might be easier to do the synthetic division with. So this is what I'm going to divide. Let me put in all my coefficients: -1, -8, -11, and then +20. Bring down. I'm going to multiply. I get +9/2. And now when I add this, I'm going to end up with -7/2. And then I'll multiply. And I get 63/2. Add the column, 19/4. And then go ahead and multiply. And I get -171/8. And then I get -11/8. So the ordered pair is -9/2 and -11/8. If I make these decimals, it's -4.5 and -1.375. Then I'll do synthetic division with the +1 as well. -1, -8, -11, and 20. Bring down, multiply, add the column. Actually, I can't do, 1 is the 0. I'm doing -1, sorry. I'm going to do a -1 here. So then this becomes +1. And then this is going to be -7. Because I needed that 0 to be in between. And I already knew that 1 was one of my zeros. So I'm actually doing -1. So then now I'll multiply. -4, +4, 24. So again, the ordered pair is the y is the ordered pair, the remainder. So now I can graph these additional points now. And this is going to tell us how our graph is going to move along. So let me come back up here. So I already have the zeros graphed. Let me get rid of this stuff here. Let me put my 0 a little bit better back. Okay, so I have one here and here. So now I'm graphing the ordered pair -4, -4.5, and -1.375. So halfway in between. And remember, my graph was going by 2s. So it's going to go really close here since I went by 2s. I'll put it right here. So it's going to come down here. And then the other additional order pair I found was -1, +24. So it's a little bit higher than my y-intercept. So it'll be up here somewhere. So -1, and then negative 24. So it's going to come up here, then it's going to come down, and then it'll come down to the other 0. And there's your graph. And again, we saw that on the Desmos down here. And notice my graph looks very similar. Let's try another example. Okay, so here is my function. Again, I keyed it into Desmos. Now when I zoom in here, notice my zeros are located here, because remember it's the comma zeros. So a number comma 0 is an x-intercept, and then a 0 comma a number would be the y-intercept. So this one's my y-intercept, and then all the other ones that I circled in pink are my x-intercepts. Notice they're crazy decimals. This one here and this one here are going to be radicals. So what we're going to see is once we do synthetic using the single rational 0 that I have, then after I get it down to quadratic, we're going to see that we can't factor it, and we're going to have to use quadratic formula. On the test, I'm going to expect you to represent your x-intercepts in simplest radical form. If you give me the decimal form like this, I'm going to mark it wrong. So for graphing purposes, you'll need the decimal version. However, when I ask you to list the x-intercepts, I want them listed in radical form. So let's go ahead, and now that we see that one of my rational zeros is positive 1, that's what I'm going to go ahead and do synthetic division with, so I can get those other 2 radicals. So let's go ahead and come back up here. Now let's also describe the end behavior. My end behavior is the x cubed, so we know it's going to fall left and rise to the right because it's based on a positive x cubed. So I'm going to do synthetic division. Let me put in my coefficients, 1, negative 4, negative 2, and 5. Bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply, add the column. I'm going to multiply, add the column. I already knew I was expecting a remainder of 0 because I knew that x equals 1 is one of the zeros. So now let me add back in my variables. So it's x squared minus 3x minus 5 equals 0. I can see that there are no factors of negative 5 that will give me a negative 3. So I need to do quadratic formula. My a is 1, my b is negative 3, my c is negative 5. So opposite of b is 3 plus or minus negative 3 squared minus 4ac, all under the radical, divided by 2 times a. And this is x equals. So again, let's simplify what's under the square root. 9 plus 20 divided by 2. X equals 3 plus the square root of 29 over 2. And again, I can separate it. So remember, you have your original one, x equals 1, x equals 3 minus root 29 over 2, and x equals 3 plus 29 over 2. Now, if you were to do this on your calculator, you're going to find that the square root of 29 is approximately 5.4, if I just round it to the 10th place. So if I do 3 minus 5.4 divide by 2, this is going to give me negative 2.4 divide by 2, which is going to be approximately negative 1.2. And then the same thing here, if I do 3 plus 5.4 divide by 2, 8.4 divide by 2, and this will approximately give me positive 4.2. Remember, on the Desmos graph, look at the numbers that were here. I had the negative 1.193. So again, if I rounded that to the 10th place like I did, and then here 4.2, the answers I just got made sense. Now, again, when you're listing them, the zeros or your x-intercepts, you're going to list them in simplest radical form. For graphing purposes, you need the decimals. However, if it asks you to list the zeros, this is what you're going to list them as. If it asks you to list them as x-intercepts, remember their order pairs. 1, 0, 3 minus root 29 over 2, 0, 3 plus square root 29 over 2, 0. These are x-intercepts. And then if you write it this way, these are the zeros. Now, let me go back and get my y-intercept. I can go back to the original. My y-intercept is right here. It's the positive 5. So it's going to be 0, 5. So let me go ahead and graph the 3 zeros and the y-intercept. And then I'm going to look to see where I need to find additional points. Now, remember when we were also listing the factors? At this point right here, when it couldn't be factored, this would have been one of the factors, x squared minus 3x minus 5. And then the other factor was this 1, so x minus 1. So these would be the factors if it ever asks you to list the factors. So let me go ahead and get the zeros on the graph. So again, remember we're going to graph the positive 1, the positive 4.2, and then the negative 1.2, and my y-intercept. So remember, we need to find additional points in between. An additional point could have been, let's see, I need to definitely find one in this section here. I could probably just go straight from this 1.2, the negative 1.2 up to the y-axis. So let me go ahead and just do one additional point there. So I'm going to go ahead and I'll do synthetic division using a 3. Let me see where I got room here. Let me go over here to the side. So I'll do synthetic division using positive 3. So 1, negative 4, negative 2, positive 5, bring down, multiply, add the column, multiply, add the column, multiply, add the column. So the order pair I'm going to graph is 3, negative 10. So this tells me it's going to go super low down here, probably down into my work. So we'll say it's somewhere here, just so we don't go too into the work. Let me make it a red point. All right, so again, remember your end behavior. So the farthest to the left 0, it's gonna fall left and rise to the right. So I'm gonna connect it up here to the y-intercept, back down to the 0, down to my additional point, and then back up to the last 0. And there's your graph. And again, notice it looks very similar to the Desmos graph. Let me do number 6 for you. Again, it's going to have another radical answer. Okay, so here's my next example. Notice this time it's got a negative number in front of x cubed. So again, my end behavior this time, when it's a negative x cubed, it's going to rise left and fall right. So let's go ahead and take a sneak peek at Desmos, and let's go ahead and see what's happening here with the x-intercepts. Let's go see what our zeros are. Let's take a little peek at Desmos. Bring this on up and notice the zeros that are located here along my x-axis are negative 2, 0. And then the next one that I see is negative 0.236, 0, which tells me this is a radical. And then 4.236 comma 0, another radical answer. So again, I can't do synthetic division with these decimals. I have to use my one and only rational 0, which is the -2. The 0 comma +2 is my y-intercept. So let me go ahead and do synthetic division using the -2, which will then bring down my polynomial 1 degree, so it'll turn it into a quadratic equation that I can now do the quadratic formula with, because again, you're going to see that it will not be able to be factored because I can already see that my 3 zeros of the 3, 2 of them are going to be radicals. So let me go ahead and do synthetic division now. Let me move the graph out of the way. Okay, so let's do synthetic division using the -2. Let me add in the coefficients. -1, +2, 9, and +2. I'll bring down the -1, I'll multiply it, add the column, I'll multiply, add the column, multiply, remainder of 0, which is not a surprise because again, I knew that -2 was a 0. So add in the variables, 4x + 1. Again, I'm going to factor out a -1 GCF just to make this easier. And again, looking at this, I can see that there are no factors of -1 that will give me a -4. So I'm going to do quadratic formula. A = 1, B = -4, C = -1. So let me go ahead and do the quadratic formula. So opposite of B, so +4, -4 squared, -4 times A times C, all divided by 2 times A. I'm going to go ahead and simplify what's under the radical. 16 + 4 divided by 2, 4 plus the square root of 20. I need to simplify the radical before I try to simplify the fraction. Square root of 20, I can break into 4 times 5, becomes 2 radical 5. So 4 plus or minus 2 radical 5 over 2. I now can simplify all of these, and my simplified answer is 2 plus or minus the square root of 5. So my x-intercepts are going to occur at x equals -2, x equals 2 minus radical 5, and x equals 2 plus square root 5. Now again, if you want to approximate the square root of 5, the square root of 5 is approximately 2.236. So I'll go ahead and figure out where I need to graph these. And notice here, I've got the 0.236. So here, 2 minus 2.236, which gives me -0.236 for this one. And then here, 2 plus 2.236 gives me the 4.236. And then again, here's this one. So again, written as ordered pairs, we already saw it in the Desmos graph. However, that would be the decimal version, but again, on the test, I want to see it in simplest radical form. So if it asks you to list the zeros, you're going to list them this way, in radical form. If it asks you to list them as x-intercepts, remember we turn them into ordered pairs. So -2, 0, 2 minus square root 5, 0, and 2 plus square root 5, 0. These would be the x-intercepts. And then again, if I go back to my original equation to get my y-intercept, it's just the constant. So it's right here, the +2. So my y-intercept is the ordered pair 0, 2. So let me get these 3 zeros on the graph as well as my y-intercept. So here is my y-intercept. I also have here at -2. Then I've got the negative 0.236, so really close to the y-axis. And then the positive 4.2. 1, 2, 3, 4, so about here. So now again, I need to look for additional points in between these zeros. So I need to find an additional point in between these two zeros, and then one over here as well. So the easiest one over here on the far left is going to be to do synthetic division using -1. And then from there, I can also plug in an additional order pair in between 0 and 4. So let me go ahead and do the synthetic division to get my additional points. Let me find a spot. Let me come over here to the far right. So again, I'm doing 2 synthetic divisions. I'm using -1 to get an additional point. So -1, 2, 9, 2. Bring down. I'm going to multiply, add the column, multiply, add the column, multiply, add the column. So I'm going to graph -1, -4 as an additional point. And then I'm also going to do synthetic with +1. -1, 2, 9, 2. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. So the order pair I'm going to graph over here is 1, 12. So let me come on over here and add these points to my graph. So I'll graph -1, -4 right here, and then +1, +12. And again, it's going to go off the graph because 1, 2, 3, 4, 5, 6, 7. I'll put it way up here. So again, let's take a look at the end behavior. Remember, it's rising to the left, so at this far 0, and then falling to the right. And now I can connect. So it's going to come down here to my additional point, back up to the 0. It's going to hit my y-intercept, reach up to my additional point, and then come back down to the 0. And again, it looks very similar to my Desmos graph. Again, I'm not looking for the lowest or the highest point. I'm just looking for a point in between to see the general direction of my graph. And then we have one more example. So when your function is already factored for you, we don't have to do synthetic division. All we're going to do is go ahead and set each of the factors equal to 0. So notice here I've got x minus 3 equals 0 because it's occurring 2 times. So I've got 2 zeros that are going to come from x minus 3. So I'm going to get x equals 3 and x equals 3 2 times because it was squared. So I get 2 zeros out of this one. I'm going to get 1 0 out of this one. And then also another exponent of 2. So 2 zeros here. So once I add all this up, it's going to end up being 5 zeros. And notice the negative sign in the front. This is going to tell me I'm going to be looking for an end behavior of a negative x to the 5th, which will be rising to the left, but falling to the right. Now, let me do the next one. X plus 1 equals 0. X equals -1. This only occurs 1 time. So there's 2 here. So this is 2 of them. So this is even multiplicity. This one, it only occurs once. So 1 time. So it's an odd multiplicity. And then the last one, x plus 1, and it's got an exponent of 2. So I'm going to get x equals -1 2 times. So this is even as well. And remember the even multiplicity, it's the bounce or the touch and turn. The odd is going to go through. So let me go ahead and put these x-intercepts on my graph. So I've got one at, actually, sorry, this occurs 3 times. Sorry, let me fix that. So this one is the same as this one. So it's actually occurring 3 times. Let me fix this. Because notice it's x plus 1, x plus 1. So 3 times is still odd, so it's going to cross there. So I'm going to add the zeros. And then I also have one at positive 3. Now, this time my y-intercept, I've actually got to plug in x equals 0 into the original to get the y-intercept. So it's f of x equals negative x minus 3 squared, x plus 1, x plus 1 squared. So put in a 0 every place that I see an x. This gives me negative 3 squared. This is a 1, 1 squared. So this just gives me 9, 1, 1. So it's y equals 9. So my y-intercept is at negative 9. So I'm going to put that way down here. Now remember, at this 0, this is the even multiplicity. There was 2 of them. So this is the touch and turn. This one, it occurred 3 times, so it was odd. This one's going to cross. I can also add in my end behavior. So remember, it's rising to the left, falling to the right. I need to figure out how it moves in between. So I need to find additional points. So I can actually just come right here and connect this 0 to the y-intercept, but I need to find another 0 in here. And I'm going to plug in 2. This one I can't do synthetic with. So I'm going to take this original equation and I'm going to set x equal to 2. So I'm going to get negative and then 2 minus 3 squared, 2 plus 1, 2 plus 1 squared, negative 1 squared, 3, 3 squared, 1, 3, 9, and I get negative 27. So I'm going to be graphing the order pair 2 comma negative 27. So obviously it's going to go way down here. So my additional point, I'm going to connect it, and then it's going to come back up here, but then it's going to touch, and then it bounces away. Other thing, remember the turning points. It was in x to the 5th, 5 minus 1. I will do a second video finishing up the last few examples.